So if you happen to go back and watch the video, you can pause right here and see how I factored it, got it all the way down to this. And as Kaylee just pointed out, we are going to balance at -2 and +2. And so there are a couple ways we can do that. We can come in here and bounce. Then we got to turn and come back up here and turn down and bounce. So it could look like that. Or is it starting from up here and bouncing, turn, come back down, bounce, and turn? Mm-hmm. There's a green one and a purple one. And they both kind of fit through all the points, correct? But there's only one right one. So what we have to do is look at our end behavior. So let me go ahead and move these out of the way. All right, and let's look at our end behavior because that's going to be the telltale sign. So when we're dealing with end behavior, we need to take the very beginning one and do y is equal to like negative. You need a negative or positive sign, x to the 5th power. And as we take x and we approach infinity, which is going which direction again? Direction is this? That's going right. As this is going to the right, what is happening with our function? Okay. Well, that means if I throw infinity in here and I go negative, and I just throw infinity in here to the 5th power, I get negative infinity, which means that the y's are approaching which direction? Down. So this function is going down. And so the other one is if we're going to the left, that means that x is approaching negative infinity, is this direction. And if I throw a negative in there, and I have negative infinity 5 times with another negative, which means there's 6 negatives, would make it a positive. That means it's going up. So you were right. It starts here. It bounces. And it's going to bounce again. Now this height of this curve here needs to be about the same. So you're not going to do something crazy here, make this really tall and this one really short. Okay? It would have to be symmetrical. It's got to be what we call rotational. What I mean by rotational is that I can take this and spin it 180 degrees and it would be back to where it was. If that pivot point was in the right spot, it would have worked, okay? Does that make sense? So it is rotational. Make sense? Crazy. Isn't that more, I don't know, I found that one more challenging and more unique than the ones we've done before. Right?
Is it mostly because
You find it exciting? Different?
it's different because it's the only odd that we've ever done?
That's the second odd. We had an odd earlier. This is the second odd that we have done. Yeah. And so I needed to have at least an odd function in because the thing is we keep talking about it, but then you don't get to see it. It's hard to work with something you've never seen. You know what I'm saying? So, so I give you an odd function so that you can see that it rotates. I wanted to have bouncing in it as well. So I strayed away from the rest of the group. They're doing day 4 on an older sheet. They're still doing, let's group this one, let's group this one. And a simple cubic that is just going to do this and bounce off 1. So I just wanted to step away from that. All right, so let me reset the page so we can take a look at these I's and I knots. All right, so first thing we're going to do is find the conjugate of this. In order to find the conjugate of that, you must simplify it first, which means that we have to find the conjugate with inside the actual conjugate we're going to find. And Kaylee knows what it is. It's what? It is a 4 plus 2i. So Kenzie, we're going to take what's on the bottom and we're going to put a plus sign with it instead. It's called the conjugate. Okay. Once we have it written on the bottom, I have to write it on top as well in order to multiply by 1, which is not changing the problem any. All right. Now I need to multiply these together. I don't know if you got it right. But I know that 4 times 3 is what?
12.
And then 4 times 2i. That's a plus 6i. And then I got a negative 5i times 4, which is minus 20i. And then in the end, I get a minus 10ni squared. And I will circle this negative 10i squared because it's really what?
A positive 10.
It is really a positive 10. How do we know that?
Because the I squared makes it a negative 1.
What's the little chant we need?
I1, and negatives in the middle. And then
So
Why
if
did
you
you
were
count
not
red?
here
honestly,
and you
shut
missed
up.
this, with the imaginary numbers, all these i's, anytime you have a power on them, we've got to simplify them. So anything that has a power higher than 1, you can simplify and then repeat. So in this case here, Kenzie, it goes 4. This is also I to the 5th. This one's I to the 6th. This is I to the 7th. This is I to the 8th. It just continues on. It repeats that same. So I to the 5th is really I to the 6th is really negative 1. I to the 7th is really negative I to the 8th is really 1. The reason why this works, guys, again, remember your number line. Here's your 1 over here. Here's your negative 1 over here. Okay? Remember that imaginary numbers are on a different axis. So in this case here, there's another axis sitting right here. Positive I is here and negative I is here. Okay? And when we're dealing with just an I, it is a 90-degree rotation. Okay? So if you wanted to, you could count it like this. So 1 I will put you here. I squared, which would be another I squared would put you at negative 1. If I do an I to the 3rd power, I put another I, that's 1, 2, 3, it puts me at negative 1. I to the 4th is positive 1, so if I put another I. So that's 5I would be, there's 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So if I want an I to the 15th, then I would be at negative I. So you could count around the circle if you wanted to, over and over and over again. Okay? So it is a 90-degree rotation and not so much. This is why I listed out like this. Okay? I1, negatives in the middle, because that's the way it works. I, negative 1, negative I, 1. It just follows the circle. That's all that is. That's why it goes like that. Okay? And then you can just count from there, Kenzie. So I can just count out how many. So in this case here, I got 1, 2. So this I squared is really a negative 1. So the math goes negative 10 times a negative 1 in here. But you guys know a negative times a negative is a positive. So I circle it because I know that's going to end up turning into a positive 10. It switches the sign. So when you see I squared, it's going to switch the sign of whatever your number is. Okay? So that's going to get combined with the 12 in front. Okay? Now, so let's go ahead and combine that all together and finish this off. 10 and 12 is 22. And then let me go ahead and add these together. 6i minus 20i. Yeah, negative 14i. Emma's kind of mouthy. All right. It's so weird because generally I would think that you just would love to talk because you love to talk. I've seen you before, right? But in the morning, it's like, it's not wake up, Alex. You're saying it. Maybe he's not. All right, so let's take a look at the bottom one here. Now you can multiply it straight out if you need to, right? Remember there's a trick to this. So you may remember the trick? Take the front number and do what? Square it. Take the back number and square it, and then you add it together, gives you this result. Okay? Now, if you miss that and you don't know how that is done, all you have to do is do what? 4 times 4, which is 16. 4 times the 2i, which is plus 8i. And then you get the minus 2i plus times 4 is minus 8i. And in the end, you get a minus, a negative times positive is a negative, and you get 4i squared. Which turns into, we just talked about it, a plus 4. And this cancels out because plus 8i and minus 8i goes away. So it is really just going to end up being 16 plus 4. That's where I get the 20. So either you could go with a shortcut, because you know it's a conjugate. That's the reason why you designed that conjugate. So it would just make the i's disappear. The reason why we have to do this, remember, we're not allowed to have an I on the bottom. Okay? Now, we are the only country that does it, but that's okay. You go to other countries, they leave the I there. Leave the radical on the bottom. Who cares? Because, honestly, who cares? But our EEOC deems it important. It is not horrible to learn how to manipulate numbers. So that's part of it. But I don't know if it's necessary. I think we ought to bring the United States into the 21st century. All right? Remove and let the radicals stand. Because there's no reason. Everybody's got a cell phone. They can say, give me 1 over square root of 13. You don't have to have square root of 13 over 13. Why do we have to rationalize it? So
Everyone else is like, what do they do things?
it's just ridiculous. All right. But again, I don't make the rules on that. Hopefully, one day Maddox will. Okay, Maddox, the mathematician, he's going to get out there and he's going to pursue this and be the I don't know, the federal government, like Becky DeVos, instead of destroying American education with her billions of dollars, it would have been Maddox saying, hey, guess what? Stop simplifying roots. And he gets the whole nation to stop doing it. Thank you, Maddox. I'm looking forward to that one day on my deathbed to watch that happen. Okay? Yeah. What's wrong with this?
It's in the triangle.
Yeah. She says the triangle rule happens here. Guys, each of these is divisible by what? 2. So we need to simplify that. All right? Which means that 2 will go in that, make that 11. 2 will go in that, make that 7i. And 2 will go in that, make that a 10. So this right here is the simplified version of that. Is that the conjugate? No, it's not the conjugate. What's the conjugate of that one? Now, just so you know, Kinsey, the conjugate means that I just take the middle sign and switch it. So to find the conjugate of this one, you just do change it to a plus sign. That is the answer. Okay. Now, another thing that will that can happen here, Kinsey, is that you might see it on the on Math Excel, and they would separate it into 2 different fractions. So just remember, this is a simplified, just writing as one number. You separate it 2 fractions. The Math Excel likes it this way. Professors like it. I like it this way. It's separating the real part from the imaginary part. Here it seems kind of glued together, and I don't like it. It just seems unnatural. Okay. All right. Let's go to the one on the right. This one here. Since I got the I1, and negatives in the middle already, I think this one's set up for that. So I'll bring it way over here and maybe erase this so we can see what we're doing. I like playing around with these. I don't know if you'll see them on the ESC. I think you'll see them on the test or something like that. So we got to kind of pay attention to it. In this case here, what we're going to do is simplify this first. So take all your powers and reduce them. So what am I going to do with this one here? That's I squared, right? Which is -1, correct? So that turns into a -4. Get that? See, Brady? This is 11. Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 gives me a -I. So this is really a -I. So this is also going to switch signs, but I still get to keep the I. So there's a negative in there, so it's going to make it a +5I. Questions on that? You see that, Megan? So, and we have 11 on it, then it's going to be a -I, so it's going to switch the sign and keep the I. This one has a 4. Where's 4? It's equal to what? 1, correct? 1 times any number is still that number. So this right here just makes the 4I disappear. So if you got an I to the 4th, it kind of just goes away. It's really just 1. Okay? And the last one, I got 11I. Not I to the 11th, but just 11I. I mean, guess what? Nothing happens. And since I'm adding these together, all I have to do now is combine my like terms. -4 and 6 is 2, and then 5I and 11I is 16I. Did you get it right? Or did you get it wrong? You have it right now on your paper. Hopefully you can write your notes down and figure out exactly what we did, and you know what to do on it, okay? So let's go ahead and skip down here and take a look at this one over. Hold on. We'll do this one over here. 5I with a 7 there. Let me go ahead and clear the ink from this. All right, so 5 divided by 7I. How are you going to get rid of that I off the bottom? Multiply by just the letter I. So I get 5I over 7I squared. And so all it's going to do here, guys, the trick to this one, anytime you have that, you throw the I on top and throw a negative out front. Okay? So the I moves to the top and a negative in front. It's that simple. Crazy. All right. You know what to do with this one? Did you get that one yet, Javante? I saw that you and him switched today. See, you're Javante. See, the Monty's. Yeah, I wish I had a twin brother that looked like me. So we would have hid it from the world, though. I would only like have one person come out of the. I just make sure I bring that food back for my brother. And then, so we would only one kid would go to school every day. Share the identity. Like so, every other day you get the day off. I don't feel like one today. All right, go on. You go to school. Okay. You just play video games all day long. Just like your mom did, though. I thought I had 2 of you. No, there's only one of us. You're gonna make twice the money, though. That's the problem. Here. So distribute the negative, and you get what? -12 minus 13I. And let's go ahead and put the 4 and the 12 together. Get you -8 and minus 16I. Questions? Come on, Kaylee. You can come on in. The door's open. Who's out there?
There's like a person sleeping. The teacher still's like, I don't care, so just leave.
Must be destructive in class. All right.
No, she just stays in the bathroom.
So what about this one? All right, so I put this on the paper because I wanted to see how many people actually thought this is exactly the same problem.
Oh.
Does it look like the same problem?
It's a trick.
It is a trick. I have a lot of people on the test who actually will multiply this out when that is really a subtraction problem. This one here is the multiplication problem. Okay, so here I will get 48. Here I'm going to get plus 52i. Here I'm going to get minus 36i. And I finally end up with a minus 13i squared. I'm sorry, 39i squared, which we know turns into a plus 39 that I'm going to add to this, which is 87. And then subtract that out, 16. You're lucky I didn't put fractions in it. Did you get 87 plus 69? Yeah, I got my math right this morning. It's an early morning. I was up at 4:30. Getting ready for school today. I practiced my times tables. I was ready to go. Prepared all my math. I was on the deck. I was on deck. Yes. All right. Any questions? Enough of this. So I think that's all of them. All right, so let's take a look at all right, so I restarted this thing yesterday, and it's still going to act up on media scrolls. This button seems to be working. Homework 4.18. Let me switch the page. So we get to finish up our quadratic notes. .18. Question time. Anybody got any questions over last night's homework? Yes. Number 4. Ray Justin says number 4. Oh, it's on the same page. Number 4. Oh. 4. All right. So on the test, remember what's going to happen. You're going to have a section that looks just like this. As I said, the homework is little mini tests every single day. You're not practicing your little mini test, then how will you do on your test? Okay. We are seeing that there's a bunch of kids that our culture has changed. COVID has changed the way we are and the way we operate. And some of you guys have just said, I don't care. You know what I'm saying? And that attitude you're going to have to change it. We were just saying, how do we change it? Well, that comes within you, not me. I can't change it for you. Okay. So you're going to have to figure out how I can do, and that's not give up. Okay. Stick with something more than just 2 seconds, and that's kind of hard because you have a device that does it every 5 seconds. You can always switch something, right? So back in the day when the cartoons we were actually showing, you probably have seen on TikTok. There's some of those where they say, all right, if you watch, it's like the images they have on some of the shows now for the kids are like every second to 2 seconds the screen switches to different character. Every 2 seconds. And That wasn't a thing when I grew up. It wasn't a thing when you grew up. You actually had a little bit longer than 2 seconds to focus on like SpongeBob or Patrick. It's not every 2 seconds. Okay.
Very intentional.
But
No,
you're
it's
saying,
that one.
so that culture is changing. It is changing the way your kids will see. So your little brothers and sisters who are actually watching these little shows, it is changing their mind, and you don't know it. Okay, it is one of those responses and wants to hit that dopamine every like 2 seconds. I just don't know what that's going to do. I don't know what's going to change, but it will change society. Okay, just like the algorithms, which are horrible algorithms that are based on making money. On social media, Instagram, and all of those things are all about money, how to make money and maximize money for the corporation, keep you watching, and that's the big stuff. So if you learn how to take your device and set it down every once in a while and say, not today, you're not gonna make any money off me today, might be a good thing. But first, you gotta be aware of it. Number one, the only way you can fix something is to be aware of it. So watch Social Dilemma on Netflix. It's a good 45 minutes, and if you haven't seen, some of the teachers have shown it in class. It is an eye opener on the way AI is running your life, and you don't even know it. Okay, and you get sucked in. I did. I'm like, I want to go in there and watch things that are enjoyable to me. So, get it? But, so the little mini test that we have basically for homework, you need to be practicing them. If you're not practicing them, you're not going to get better at it. Okay, that's my whole point here. Let's take a look at number 4. I got to solve it. So what's the first thing we got to do when we solve? Correct. Set it equal to 0. What I would want to do is make sure that the x squared is positive, so I'm not dealing with a negative x squared. So I'm going to subtract the 2x squared over here. I'm going to do that in my head here. I know that's going to end up being x squared. So therefore, I want to move the 9 over here as well. So I'm going to subtract 9x as well. We get minus 8x minus 12. Now that is equal to 0, and I'm going to try to factor it. That's the very first thing I want to do is try to factor it. Okay? So once you move the 2x squared over, and once you move the 9 over, it looks very factorable. Because I got 1 times 12, 2 times 6, and 3 times 4. So we start to look at this a little bit closer. That is a minus 12. That means that is positive, that is negative. I cannot switch those signs. I can make it minus and positive, but they have to be different. There is no way, all right, that out of these numbers up here that it's going to happen. Because 3 and 4 will give me a 1 when I subtract, right? A 2 and a 6 when I put them in gives me a 4 when I subtract them. Because 1 will be positive, 1 will be negative. And 1 and 12 will give me 11. So it will not factor. Even though it was like, oh, it looks good, it doesn't factor. All right, step 2, quadratic formula or square root methods are the only 2 options we got left. 12 is looking pretty gnarly, fairly large. Probably don't want to do with that. Maybe complete the square. And not only that, it is really nice setup because that's an even number. If that was a 7, I would push myself towards a quadratic formula. Does it make sense? But since I can take half of 8 pretty easily, then I can do that. All right, so x squared minus 8x plus blank minus 12 minus blank, set equal to 0. Set your parentheses up. You know you're taking half of 8, which is 4. Squaring is 16. So this factors down to x minus 4 squared, and this gives you minus 28. Equals 0. You with me? Any questions on how I get my numbers? The time is now to ask. Good with that? All right. Gotta solve it, so what do you do with the 28? Put it over the other side. So we're gonna add the 28 to the other side. Then I'm gonna take the square root. That's gonna give me x minus 4 is equal to 28 breaks down to 4 times 7, which is 2 times 2 times 7. I pair 2, so I get 2 square root 7. Go ahead and simplify that. Now what? Piecewise, correct, which turns into plus or minus. Add the 4. So x is equal to 4 plus or minus 2 square root 7. Now, if I need them as intercepts, put an OP on it. Good question. I liked it because it was fake me. It was like a fake. It's like, whoop, factory. Oh. Like when you walk in the cow field, you know, with your shoes off, stepped in it. Ah, dang it. Then you realize, I didn't feel that bad.
Oh, okay.
My grandfather. I asked my grandfather because he had legs. He lost his leg in a farm accident when he was older. But I would ask him questions about, well, what did it was like when he was like his life? So he would walk to school barefoot. And one of the things they like to do is jump in the warm cow patties on the way because you got to feel that squish between your toes. It's like good. So they would go to the schoolhouse. And they would always smell like manure all the time. All the farmers did. So it always smelled like manure at the farmhouse, the schoolhouse. And so, mom, they kind of got, I guess, word of they're coming in smelling like cow manure, decided to buy them shoes. So they got him some new shoes. And so he put the shoes on, but when back then, they weren't Nike. They were made of hard leather and a little hard sole. And you put them on, your feet would blister and bleed. And so my grandfather would have, he would be like, these are uncomfortable. So he'd put them on and he'd walk behind the house. He'd take them off and there's this tree and there's a little hole in the tree. He'd shove them in there and walk to school and still go. And come back.
So
and
you
then,
just went to school
and so,
in their shoes?
huh?
You just went like all day at school in their shoes?
Yeah, well, all of them did. That's the thing. So, I mean, school wasn't very long for them because it was just learn how to read and write basically and a little bit of math. I mean, that's all you really needed for farmers. So he went through and so what happened was mom had caught wind and found that he wasn't wearing his shoes to school. And where's those shoes we just bought you? And he went out there. He had forgotten to grab his shoes from the tree, but mom had already found them. And so he went out there. It was like, he had to come back in. It was like, I don't know. But he was telling me, he was so like dejected. I don't know. And he got beat so hard. Because back then they used to beat the kids, so.
No, they would make you go get like a switch. And if you
I had to get my switch when I was a kid too. So.
The right
But he got smacked pretty good. So he'd started wearing the shoes, but his feet would blister and bleed. And this is horrible. He hated it. It was the worst thing ever. And so I just love that feeling of the manure between my toes. I was like, what? I'm ready to throw up myself. You know what I'm saying? But in the good old days, what do you say? But can't go back to that. All right. Good morning. Alex from Red.
So happy that she came in and just delivered it as soon
I
as
know,
she finished.
right? Stop that story.
I would feel so bad if she's walking.
At least it went to the right Alex. There's two of them. All right, now So, any other questions over homework?
$12.
12 and 13.
No, it's 13.
13? Just 13. If I'm looking at number 13, again, this is that one where you have to use I1, negatives in the middle. So I see an I to the 10th there, right? So you go through your little, and so you have your I1 negatives in the middle. So I'm going to count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative this is being a negative 1. A negative times a negative is a positive 1. And so that needs to go in with the 5, which makes it negative 4 minus 6i. Yes.
16.
16. If I'm looking at number 16, the first thing you need to do is rewrite this one as 2i. And then distribute the negative here and here to make that 7 plus 5i. And then if I've got 5 plus 2i plus 7, then I can add the 7 and the 5, which is 12. 7. Next question.
That was a weird yawn.
It was a weird yawn. What are you yawning for?
Why are you tired? Did you go to sleep?
Because she was riding a bicycle.
I don't know.
She was too tired.
And not a question. I said, oh, she was running a bicycle. I don't know. Yeah.
Hey, Justin.
Huh?
No, I don't know. Maybe. I was gonna say, all right.
Do it
So-
for your
so-
own sake. It can't be worse than what I called
Okay,
a
so,
mistake that
Justin,
one
so
Go on.
what do you call a cow with no legs?
Hi, ground beef.
What do you call a cow with 2 legs? Your mom.
Ah, you're so funny. I did a fun your mom joke, guys.
Most people say lean beef. Yeah.
What do you call a sleeping cow?
Sleeping cow.
No, what do you call a sleeping cow?
Moo.
A bulldozer.
A bulldozer.
Oh.
You're so funny.
That is. That was good. Bulldozer. What do you call a cow? It's jumping over a barbed wire fence.
Do your mom.
Under construction.
I know another cow joke that has to do with math too. I used to ride it too.
This is
I like cows.
eventful class.
That's a
All right.
fun.
So, guys, make sure you can use your calculator. Does everybody have a calculator? Because you're going to need one. All right.
I have a calculator on my phone.
Let's go ahead and get a calculator out and at least try this problem right here. I plan on, actually, I think I'm going to give a quiz tomorrow. I'll calculate a quiz tomorrow. So,
What? Kill me.
have your calculator ready.
I don't
Yep.
know how to use this thing.
I hope you learn how to use your calculator by tomorrow.
Yeah, I'm just going to come into my next second class.
I'm going over it right now. I'm going to teach you right now.
Yeah, but I don't
Teachers. I can promise you the page turn and
We should have a day of
It's like
class where
chocolate.
we just do the really bad jokes. And we don't do that.
honestly,
Let's
Yeah.
do that right after our final exam.
Yeah, sounds like a good plan. All right,
You
now.
have so much time to get like jokes written down to remember.
No, I already have them memorized.
I was about to say, he really can't memorize it, honestly.
All right, so I'm grabbing my calculator as well right now so you can see what you're supposed to be typing in. So let me open this up here.
Honestly, I'm scared too.
Yeah, most people they were ground beef, and then with 2 legs they always say lean beef, and then I say, nah, sorry, your mom.
No, we're not. Sorry.
It's pretty funny. My daughter did it to my son at the dinner table, and my wife was sitting there. It was pretty embarrassing.
He did not.
She did it, not him. All right. So grab your handy dandy calculator. Anybody need one to borrow? You need to make sure you bring in your own tomorrow. I don't know how you're gonna find one from your friends or whatever.
I'm just
Then you need to get a
battery.
charger.
Yeah. No, I use a battery. I'm just gonna get batteries tonight.
Anybody else need one? I've got. This is somebody else's. I'll let you borrow it. Again, the library doesn't have any to check out at this time. You can check every time. Sometimes they find some get turned in, some don't.
Yes.
But guys, you bring your own in, please. Again, on the EOC, I cannot loan out calculators. Okay. You cannot trade calculators, and so it's not going to happen for April sometime.
Oh,
right, now.
okay.
I thought you were saying it was like next month.
Yeah, I thought it was like in December. Thank God.
All right, so go ahead and clear these. I'm going to clear these now. If you want to, again, it is second plus 712. If you want to clear it, which is probably not a bad thing to do,
Like clear the y equals?
to clear the computer.
To clear the RAM.
Second plus, which is your memory. Then you hit 7, 1, 2. Now, if you have the ones I just handed out, the gray ones, the little small gray ones, those 82s, it is second plus 3, 2. All right, it's an older model 3, 2. All right, now what that will do, it will set your window, it will set everything back to normal. Then we're going to type in this information. Okay. So I am going to type in on this calculator.
You don't be playing the tricks on this. You better do the negative bracket.
Oh, there's a subtraction side. I don't know.
So let me present the calculator screen. All right. So again, in this case, we're going to type in this information. Negative 16. The negative 16, use this negative button, and then 16, and then the X. The squared button is here, or you can use the caret symbol. Whatever you use, make sure that you arrow the next part, the blinking cursor is in the lower part. Then we're going to put plus 64X in, and then plus 100. Yep. You don't have to hit enter. After that time, you can go ahead and hit graph. All right. Once you hit graph, you're going to get this. Okay. And so in this case here, it says we want to find the height of the pumpkin in 1.5 seconds. So you're going to go to second, calculate, and anytime you're talking about time, if I give you time, then you can use value. It's underneath the trace button right there next to the graph button. So it's second, that button. Then you go to the value and hit enter. And we're going to type in 1.5. So 1.5. Hit enter. And it's going to give you 160 feet. So that means that in 1.5 seconds, the jack-o'-lantern is going to be at 1.5 seconds. It's going to be 160 feet in the air. Make sure you use your units, okay? Now, the next one, it says, what is the maximum height of this jack-o'-lantern? The max height is the vertex, right? Well, I don't see the vertex here. So we're going to adjust it. Go to your window, and let's adjust this to see if I can get my vertex on there. Go to the Y max, and let's type in 200. 200 usually makes it and should work. 200 to 300 would work. It doesn't matter which one you put in. It shows it up. Now I want to find that maximum. So you go second, calculate. Number 4. It says I want to be on the left side of the maximum. It already is. So hit enter. So right bound shows up. And then slide this arrow, a cursor over to the right side of the maximum.
Why do you want to stop it?
Doesn't matter as long as you're on the right side of the hump. And then hit enter 2 times. And it gives me in 2 seconds, it's going to be at 164. So just round that. There's a lot of 9s there. So some of them will come up with 2.00. Some of them will come up to 2. Some of them come up with 1.999.
As long as you get the 160.
Correct. 164 is your maximum. So in 2 seconds, and the questions ask you right there, when does it reach the height? That's 2 seconds. How high does it go? 164 feet. And then which characteristic about the graph represents when the jack-o'-lantern hits the ground? Well, if I'm looking at this picture, and this was the catapult shoving that jack-o'-lantern right there, that's where it's going to hit the what? The ground. So the x-intercept is that. Now we need to find that x-intercept. So you can go to second, calculate 0, which is number 2, or root, if you've got the gray calculator, which is number 2. You just need to be on the right side of that point, which we're already on the right side. And then, whoops, something happened there. Let me go back to second, calculate number 2. I want to be on the left side of that. Oh, I see why. I'm not hitting enter. I got to hit enter. And then I want to be on the left side of that. Since I'm below it, I'm underneath it, which would mean I'm to the right of it. And you can see how my lines kind of line up for that. And there it is. In 5.2 seconds, it would hit the ground. Okay? You would have a smashed jack-o'-lantern right there. All right? So that's how you find all the information. The only other piece of information I might ask for is the y-intercept. And what would be the y-intercept? 100. Why is it 100? Because that's the top of the hill. That's where we shot the catapult. If I ask you for contextual domain, what would you put down? In context, what's your domain? All reals? So we got negative time. See, T, this is T, right? Real quick here, if I'm looking at this, Javante, T stands for time. So does negative time exist? No. So that means only from 0, time starts at 0. When does it end? Contextually, when does it end, guys?
5.1.
This jack-o'-lantern exists from here to there, correct? It doesn't exist below the ground. So contextually, this is only going from 0 to 5.2 seconds. That is your domain. Does that make sense? Or does it not make sense? Okay, so if I say in context, what's your domain? It's from 0 to your x-intercept, because you can't go below the ground, all right? And then if I say, what is your contextual range? What's the lowest the jack-o'-lantern goes? 0. What's the highest it goes? 164. So 0 to 164. So you're going to see, I may ask for, in context, what is my range? In context, what is my domain? And you need to be able to state the contextual domain and range, not what it is for any parabola. Yeah, for any parabola, yes, it's all reals. And in existence, if we're looking at parabola, it goes from negative infinity to 164. But this is not the story. I'm talking about a pumpkin. All right, or pumpkin, as you guys would say. Because I like to call it a pumpkin. He's just a punk. He's a kid. All right. You guys can do that tomorrow?
No.
Bring your calculator. It'll be hundreds. So what I would do here is I just want hundreds, so that means you take the number on the right. If it's between 1 and 4, you leave it alone. 5 or higher, you will change it. So if that was a 5, that would be 5.21 seconds. Okay. Want to deal with hundreds most of the time. For us, that just makes numerical sense because almost everything is in pennies for you guys, except for gasoline, which is in thousands, which is weird. It seems weird. No. To create a plus or minus? No, it will not. You can program your calculator. There are ways you can go into the program and design that to actually pop up. So then you can put in A, B, and C, and it will spit it out for you. It's not really, it's not legal to do that for the ACT. But most teachers who are, most teachers who are proctoring the ACT don't know how to clear a calculator. And they don't ask you. But once you hit second plus 712, it will clear that, all your programs and everything too. So, so if you have games in your program, don't hit second plus 712. But I don't know. All up to you. I know we really got in trouble. I don't have them clear. I just look and see if you have the right model or not, because I want to be consistent like with all the other teachers, even though I've got advanced knowledge on that. I don't proctor very many ACTs anyway. So, all right. Questions? Any other questions on that? You guys good with the calculator then? If not, make sure you practice before tomorrow. All right, so we're finishing up our notes from yesterday. We're going to go right to this example. I think we may have already done this example. Oh, fun. We did this one yesterday?
Was it negative 8?
We never did 5x squared plus 6.
Yeah, we did that. Well, all right. So the main thing is knowing this, right? We got to memorize this. And by B block and C block, we actually came up with a way. We're always going to start with discriminant. Remember, there's certain parts of this. Remember the beginning part, the negative b over 2a, is your axis of symmetry. Remember that this is your discriminant, which is underneath your square root. It tells you how many roots you have. It has, well, in this case here, you always have 2 solutions, all right? But you got to know if you have a double solution. If this is 0, then you have a double solution at 1 point. And then the other ones, you have 2 real or 2 imaginary. So if this b squared minus 4c is negative, you end up with 2 imaginary, right? Because you got negative square root. Negative underneath the square root means that you're going to do it. Now, this, so you got to know your parts. So what we propose to do in the other classes, we just say A is equal to 1. And we'll do this one real quick. B is equal to -4, and C is equal to 6. So to help you out with this is all we're going to do. First thing, write down your B squared minus 4AC. It's pretty easy to memorize, right? And do the math on that. So you do the B squared, just do that in your head. So -4 squared is 16. After that, you're going to take -4 times 1 times 6. And you're always going to multiply this out next. Okay? So you're going to multiply those three numbers. Those three numbers multiplied together give you a -24. And then 16 plus -24 is a -8. Now remember, this is the part that's underneath the square root. If you have a -8, how many solutions do you have? You have 2 imaginary solutions. All right? Because that negative is going to turn into what letter? Correct, a Q. All right? What were you going to say?
I was gonna say Q.
You weren't? What happens when you take the square root? What does the negative turn into? To I. Oh, that's right. That's an I. This is going to end up being 2, 2, and 2, correct? With a -1, and I'm taking the square root of that. I circle the -1 in a pair of 2s. I get 2i root 2. That is what is underneath the radical. So this whole thing that we just did, b squared minus 4ac, we already did this part. This is the hardest part for you. When I'm using the quadratic formula, this part, again, if you're going to screw up, I know you guys can do the opposite of B over the double of A. That's easy. You can also double A over here. Where do you guys screw up? In here every single time. Every single time. I'll get -16 half the time right here. All right? And then you'll forget the A. You won't even put the A in there. So I don't need an A. Just 4 cows. No, it's 4 awesome cows. All right? So remember this. You got to memorize that. Now, this, all you have to do to finish this up, put a plus or minus in front of that. I need a double A. What's A in this case? 1. So double it. You put it underneath that. I'm putting the double of A out here, and I'm going to put the opposite of B. B was what again? A -4, right? The opposite would be a +4. This is almost my solution.
Oh, we're going to simplify.
Because all I have to do now is make that a 2 plus or minus, and what happens to your 2's here? They cancel. So I get I root 2. This is my solution. If I want an ordered pair, there it is. So these 2 points never intersect the actual coordinate graph of the x and y coordinate graph. Okay? It intersects laterally, some out here, somewhere in space. Okay? All right, let's try the next one. Did we already do the next one? Come on, okay. All right, now you can. Ready, set, let's go. A is what? You always start with b squared minus 4ac. B squared minus 4ac.
I just wrote it. I don't know.
We found it. We got 2 more examples. Well, thank you for trying. I was watching Dexter last night. I'm worried about Brooklyn. Dexter, come visit you. You ever seen an episode of Dexter? The mass murderer. I mean, he's a crazy guy who kills mass murderers.
So you know that,
Huh?
you know that new show, You?
You?
Yeah.
About me?
No, it's just You. It's called
Yeah,
You.
it's about me.
Yeah.
I don't have a show about
Sure. So my friend sent
See
me,
Laura Ingram
so
suffer
good.
with that one?
My friend sent me a text. She was like, "I'm watching you." I'm like,
Yeah, and I was like, and then
I was like, okay.
It's creepy if you haven't watched it. You need to watch you.
It took me off guard.
I'm watching you.
She was like, "I'm watching you," and I'm like,
Kaylee, I'm watching you.
Yeah. Justin.
That's what the part where you're trying to. Adding on everything.
4 minus 4 times -1 times -2. Guys, what did you end up with way over here?
I was scared.
What is a negative times a negative times a negative?
Would it be a negative?
That would be a negative. And 4 times 2 is 8. So you end up with -4. All right, now, guys, remember, this is the part that's under the what?
Root.
The root. So we end up with 2 imaginary solutions. You're going to be asked the question, and it will be, and you won't have to do anything to it. I will ask you how many solutions you will have, what type they are. There'll be like to real, to imaginary, only one. It'll ask you all sorts of different things. So you make sure you know.
There's always 2 real ones, but
There's always 2 solutions.
But
But you need to know, in this case, is there one double solution? Is there 2 imaginary solutions? Or is there 2 real solutions? All right, now, so end up with 2 imaginary here. Remember, what's the square root of -4 turn into?
No, wait, no, that's so stupid.
What's the square root of -4 turn into? Now, that's 2, and that's an I.
Yeah, that's what I'm.
You put a plus or minus in front, and then you got a double A. A in this case is what? -1. So I get a -2 here. So what does that do to plus or minus? That makes it a minus plus. Did it really change anything on that right side? No. It's kind of funny. It was a plus minus. It's a minus plus. Because when you take the minus and minus divided into the negative makes it a positive, and the positive divided by a negative makes it a negative. So it just doesn't do anything. But on the other side, it will change it. We have the opposite of B, and B is in this case what?
It's got 2, so
Is it 2? So it ends up being -2. But on the bottom, we get what? -2. And negative divided by negative is a positive 1, plus or minus, and the 2's cancel here. Oh, wait. Let me go ahead and OP it just in case. Whoop, whoop. All right. Look at the next one. Let's try this one. What are we going to put it into? E squared minus,
4, 8,
what do you get? 36
minus 4 times 1
times 13. Remember what to do next?
multiply.
Fix that. 4 times 13. 52. 52. And then 36 minus 52 is negative 16. All right, negative 16.
Put square root.
So I end up with two imaginary solutions. And then in this case here, you're right. I need a square root. Then I need what? A plus or minus. And I need a double A, which is 2. And I'm going to put a double A over here. And then I'm going to do the opposite of whatever B is, which is here. Anybody have that memorized yet? Okay. Again, if you kind of work it this direction, I want to tell you that you'll have more success at it by doing the B squared minus 4AC first. Get that out of the way, simplify it so it makes it a little bit nicer for you to work with. The 16, negative 16 is what again? 4I is correct. So this is really 4I in here. Oh, wait, no, it's not 4I in there. It is 4I when we're done. So I know this is going to be 3, correct? And this is going to be plus or minus, and I have 4I over 2, which is just 2I. X. All right. Fun, under the sun. That's all she wrote.